Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to my channel and hit the bell icon to get notified when I post my new videos. So today we will be discussing centroid of a I section. Here I have typically taken a numerical which is I section. It is unsymmetrical I section. Here this portion is called as flange and the middle part is called as a web. Now here the flange is top flange is of 80 mm, bottom flange is 25 mm and thickness of the flange is 24 mm bottom and 10 mm top, and here we are supposed to find the centroid of this I section in both x and y axis. So here I can give you an easy solution for this. So here first I need to calculate this by using the bifurcation method. I am dividing this into three rectangles. So naming this as 1, 2 and 3. So this rectangle, I will make this as a column, object, first column as object, second one it is area, and this is in terms of mm square. Area is in terms of mm square, and x, y, ax, ay. So here x is in terms of mm, millimeter, and y is also in terms of mm. So ax mm cube, area is in mm square and x is in mm, so it is in mm cube. So this is also is in mm cube. Area multiplied by x and area multiplied by y. Here x and y represents the centroid of individual rectangles which we have divided 1, 2 and 3. X bar and y bar represents the centroid of overall I section. Now first object is rectangle 1. So here rectangle 1 I have taken into consideration. So area of the first rectangle, it is length into width or width into thickness. So length here is 80, thickness is 10, so it is 800 mm square. So it is in mm square. Next, x represents the horizontal centroid for this. So before going to that, I am going to put the reference axis. I call this reference axis horizontal as 1, 1 and vertical as 2, 2. Now, with reference to the vertical centroidal axis, I am going to find out what is the x. So, here I am going to bifurcate this and mark this as center point as G1. G1 represents centroid of the first rectangle. What is the distance, horizontal distance with this x1, with this rectangle 1 with reference to 2, 2 axis represents x1 and with reference to the 2, 1, 1 axis it is y1. So this is y1. So x1 is always equal to 80 by 2. So this is 40 mm. y1 is from 1, 1 axis, the distance between 1, 1 axis to this centroid G1. So here it is 24 plus 40 plus half of 10. So 24 plus 40 plus half of 10 is 5. So 40 by 10 by 2. So this represents the x and y. Next is ax and ay. Next is ax and ay. This is the ax and ay value. So 800 into 40, that is 32,000. So here 800 into this comes out to be 69. So it is 55,200. Next, coming on to the rectangle 2. So rectangle 2. So in this rectangle 2, this is the wedge part of the rectangle. So here the length here is 10, width or depth here is 40. So 10 into 40, it is 400, and x here is same. The value of x1 and x2 will be same. So this is x2. So if I just get the centroid of this is G2. From G2 to the 1 axis will be the Y2. So Y2 will be 24 plus half of 40. So 24 plus 40 by 2. So this comes on to be equal to 44, and this is here 80 by 2, same as that of x1. So we need to calculate ax and ay. So 400 into 40, so it is 16,000, and this is 44 into 400, so it is 17,600 ax and ay. The last one, so this is rectangle 3. So rectangle 3, so here it is the centroid I will mark here. So this is equal to G3. So the value of area will be 25 into 24. So value is 24 into 25 comes on to be 600, and the x will be same as x1. So 80 by 2 itself. So y will be the distance from this centroid G3 to 1, 1. So this will be your y3. So y3 is equal to 24 by 2. 24 by 2 is 12. So here the ax is 600 into 40. It comes on to be 24,000, and this one is 600 into 12. It comes on to be 7,200. So 7,200. Now we are going to add all this, that is sigma a. So addition of all these three areas of the rectangle, 800 plus 400 plus 600, it is 1,800. Now we are supposed to add this also, sigma ax. It is equal to 32,000 plus 16,000 plus 24,000. It comes on to be equal to 72,000. Sigma ax is equal to 72,000. Then sigma ay, it is equal to 55,000. Here I have found out sigma a, sigma x, and sigma ay. So last stage is finding the x bar, that is horizontal and vertical centroidal axis, x bar and y bar, that is sigma ax by sigma ay, sigma a. So sigma ay by sigma a, I will get the y bar. So sigma ax, it is 72,000 divided by 1,800. I got it as 40 mm. Then y bar is 80,000 I got, divided by 1,800 is sigma a. So I got it as 44.44 mm. So this is the horizontal and vertical centroidal axis for the given I section. Thank you for watching. Please like, share and subscribe the video. Thank you.